Looking at problem solving again, this is the last three types of questions that we kind of look at, and all they're doing is kind of reiterating what we've already gone over. So when we're looking at our problem solving, we always want to label our variables, figure out some sort of equations, then solve using substitution or elimination, and state our conclusion. Looking at this is very similar to the questions we've already done, but right now we're just changing the way it looks. So now we kind of have mixtures of candy. So we have a $2.50 candy, a $5 candy, and we're making a $4 candy. Okay, we know we're going to have 100 kilograms in total. So that kind of negates what we're looking at here. So what we need to do is let X be candy A, let Y be candy B, and this is the amount. I should say let X be the amount. Whoopsie. Be the amount of candy A, and let Y be the amount, and it's going to be of kilograms of candy B. Okay, so we know that X plus Y equals 100. And now we're using those costs. So anything that we have of X is going to be 2.5 times X plus 5 times Y equals, and in this case, this is the thing that we get confused with. We're going to have 4, which is 0.00, our cost, but we're timesing that by 100. So in that case, we'd have 400. What I'm going to do is I'm going to times the first whole equation. We'll do elimination this time by 2.5 to get rid of my x's. So we're going to get 2.5x plus 2.5y equals 250. We're just going to move this one over and simplify it. 2.5x plus 5y equals 400. We've got 1 and 2. We'll do 1 minus 2. And then I'm actually going to call this 3 because that's going to help us right at the end here. So this is going to be negative 2.5y. And then this is going to be negative 150. Remember, when you're moving down, you want to make sure you're paying attention to the signs so that you're not messing anything up. So we divide both sides here by 2.5 or negative 2.5. We're going to get y equals 60. If I sub that into what I called 3, which was our original equation, that just gives me x equals 40. I can just do that by looking at it. So now, therefore, we've got 40 kilograms of candy A and 60 kilograms of candy B. Okay, moving on to the next question. We've got a riverboat traveling with the current and without the current. So this is a very common question. What we are going to be doing is we're going to have let x be the speed of the riverboat in still water. So this is without the current because we want to know the speed of the boat in still water and the speed of the current. So those will be our let statements. Let x be the speed of the boat. And that's in still water, and we're going to let y be the speed of the current. Now, current is which way the water's flowing. Now, when we're looking at this, a riverboat took 2 hours to travel 24 kilometers going with the current and 3 hours going against the current. So what that means is with the current, we would have x plus y. Without the current, or against the current, it would be x minus y. Now, what are these x's and y's? Well, these x's and y's are speed, and we know that speed is always given in kilometers per hour. So what I need to do is I need to take my kilometers, and then with the current, it was 24 over 2. Without the current, it was 24, or against the current, over 3. Okay, so what I'm going to do is I'm going to just erase that so I can move across here. So now this would become x plus y equals 12. And this is going to be x minus y equals 8. Now I could use either equation. It doesn't actually matter. You can add or subtract, whichever one you like. We haven't added a lot in the notes, so I'm going to just do 1 plus 2. That's going to give me 2x equals 20, x equals 10. If x equals 10, then that means y equals 2. I'm just looking at equation 1 there and solving for them. Therefore, the boat is moving at 10 kilometers per hour. Oh. And the current is 2 kilometers per hour. All right. Now this last question is very similar to the question we did in the last note. We're looking at distances traveled, how fast we're going, and time. But this time we're trying to find out how many hours. In the last question, we were finding the distance traveled. So what we're going to do is we're going to let x be the time on the bus. We're going to let y be the time on the plane. And we'll work through our equations. Okay, so we're going to have x plus y. We know that that is going to be 3.5 hours. Okay, that's how far how long we've traveled in total. We know we were traveling at 40 kilometers an hour on the bus. So if we have 40 times x plus 500 times y, that's going to give us our total distance. This was the distance traveled on the bus. This is the distance traveled in the plane. So our total distance was 830. Now in this case, we'll solve by substitution. So I'll rearrange this to be y equals 3.5 minus x. We'll call that 1, call that 2. We'll sub 1 into 2. And now all we're doing is we're going to have 40x plus 500 times 3.5 minus x equals 830. Again, we've got to do a little bit of algebra here to make sure that we're getting things right. So we're going to get 40x plus 1750 minus 500x equals 830. Now 1750 is going to minus over to the other side. We'll get 920. We've got 500 minus 40. It's going to be negative 460. And that, if you look at it, actually works out really nice, because if we divide that, in most questions, it will work out like that. We get x equals 2. From equation 1, we're going to get y equals 1.5. Therefore, Lara spent 2 hours on the bus. And that was actually all we had to find. We didn't need to find y. We just did. It just asked for the bus.